Okay, kids? So this section, kids, we're going to start looking at this idea of finding distances between parallel lines and from a point to a line. I remember yesterday we talked about this. If I'm standing right here and the wall is my finish line back there, and I want to say, how far do I have to run to get to that wall? How would I measure that? From where I'm standing right now to that wall, how would I measure it?
Straight to it.
I'm going to go straight back to it. So the path that would pass through me, or the path I would draw to walk on, how would that path cross that finish line? In other words, okay, so they're gonna intersect each other so that they form a 90-degree angle. It's gonna be perpendicular to each other. So what we're doing is we're saying the distance between a line and a point is going to be the perpendicular distance that that path to that point takes, such that it forms a 90-degree angle with the finish line, or the line that we're referencing from. So today we're going to look at, well, nothing now, parallel and perpendicular lines. Question we want to ask ourselves is, how can you find the distance between two parallel lines? And this is going to be pretty short today. All right? Goals to accomplish this today. In order to answer our question, we need to be able to prove the slope criteria for all parallel lines. I think you're going to find out you know a lot more about this than you think. We're going to look at finding the distance from a point to a line. We've done that. We're going to kind of shorten the work with some tools that we're going to use today. And then we're going to use those ideas to find the distance between two parallel lines. Guys, in this room right here, this wall to this wall, if I said measure the distance between the walls, how would you choose to measure that?
Straight to it.
Okay, this to this, but would you measure from that corner to the opposite corner? No. You want to measure it so that the transversal, if you will, on the floor is related to the walls in such an angle that is 90 degrees. What's a word that indicates 90 degrees of intersection? We want stuff to be perpendicular. Okay? Today, everything's going to tie in with parallel lines and perpendicular lines. Parallel lines right here. Help me out, kids. Volunteer to read this. What are parallel lines again?
Two distinct lines with the same slope.
Two distinct lines with the same slope. So as I look at this right here, if I have a slope, rise of 2 and a run of 3, and let's say that this slope rises 4, what would the run have to be on that line to keep those parallel? 6, because 4 over 6 reduces to what, kids? Okay, so parallel lines are going to possess the same slope. We've known that. We've talked about that. We've known that for a while. Okay? So what I'll say here is this. The slopes are equal in order to have parallel lines. Okay? By the way, an equal sign, what kind of lines does an equal sign make? Parallel. That's how I remember it. Slopes equal. The equal sign's parallel, isn't it? All right. Perpendicular lines then are going to be two lines. They're perpendicular if and only if, and this should be the product of their slopes is -1. We haven't talked about that much, but we know the relationship for perpendicular lines from previous sections. What's true of their slopes if they're perpendicular? How are they related to each other? They are opposite reciprocals. Good, Maddie. Okay. So as an example, if these were my intersecting lines right here, these were my intersecting lines here, and they intersect in such a way that they form a 90-degree angle. Quick question here. I'm going to tell you the slope of this line right here, M, is 2/3. So rise 2 and run 3. If those two lines are perpendicular, what's the slope of the other line going to be? -3/2. Yep. The opposite part means change positive to a negative or vice versa. And then the reciprocal part, change numerator and denominator. So as this slope right here is 2/3, the slope of my perpendicular line to that would be what again? Excellent. -3/2. Okay. Quick question, kids. As far as slopes are concerned and how they're related to parallel and perpendicular lines, do you understand that parallel lines have the same slope? Good. And the relationship between perpendicular lines, what's true about their slope? Opposite reciprocals. Here they talk about their product is also what value? negative 1. Here's what this is talking about. It's saying take your two slopes for the lines that are perpendicular. In this case, 2/3 and negative 3/2. Multiply them together, see what you get, kids. Numerator product, 2 times negative 3. What is it? Negative 6. In my denominator, how about the 3 times 2 part? 6. Very good. Okay, 6. Hey, how about negative 6 over 6? What's that simplify to?
1. Negative 1.
Negative 1. Very good. Is the product of two slopes that are perpendicular to each other negative 1? It is. Okay? I like the idea of talking about opposite reciprocals. I think we're more comfortable with that. We've had more exposure to that. But if you also want to think about perpendicular lines and relate them in such a way that the products of slopes is negative 1, it's okay to do that too. Okay? All right. So some things to remember in order to succeed in this section. First of all, do you have decimals up and ready to rock and roll?
Yeah.
Secondly, do you have that distance formula calculator out, ready to rock and roll?
Yeah.
We've done plenty of distance formula. I'm not assessing that. So here's how this is going to work today. Things to remember. Okay? Parallel slopes are what again? They are the same. Okay, what's going to be really important for you are these next two bullets. Perpendicular slopes, again, are opposite reciprocals of each other. Okay? Parallel slopes are going to be the same. Perpendicular slopes are going to be opposite reciprocals of each other. So, that said, this is one that's maybe the most important. Okay? Recall point slope form. Okay? This is going to be important. And the reason I'm giving this to you is because a lot of the problems are going to talk about what's the distance from a point to a line with a given slope. So we're going to need to know things about points, and we're going to need to know things about slope. Anybody remember that, by the way? Formula for point slope form? There are some x's in it. It's not x2. How about I start it? You're thinking of slope right now. Okay, you're all kind of on the right track, though. That's good. How about this? Let's start out this way. It is y minus y1 equals m. Anybody remember what goes in parentheses? Okay, what I'll tell you is this. Y1 and x1 are some number. x1 comma y1 represents your point. So if I'm talking about the point 7 comma 2, my first point that I start talking about is 7 comma 2. What would the x1 value be? 7. And what would the y1 value be from 7 comma 2? 2. Okay? The slope that I talk about right here a lot today is going to be the perpendicular slope that we're going to look at. All right? But very important things to remember right here in terms of being able to, what's the word again? Succeed in this section. Okay? I really like this section. I think that when you see these two examples, you're really going to be like, oh, it's that easy, person. And we'll be like, oh, it's that easy, kids. Oh, yeah. Funny thing is, I'm recording this right now. All right? Hey, do you have down what you need right here, kids? All right, let's talk. Let's talk. Page 2, really important page right here. I'm going to be very honest with you. I told kids first hour, second hour, fourth hour. You're either going to pay attention to this, it's going to make 100% sense, or you're not going to pay attention to this, and you're going to look at the side and be like, I don't have a clue. Okay? My suggestion would be to pay attention. And you guys do a good job. Okay? All right. First things first. Example 1 is talking about finding the distance from what to what, kids? Point to a line. Okay. In this example right here, it says find the distance from which point? 6 comma negative 2. That's like the first point they give me. I'm going to say, you know what? That's kind of like an x1 comma y1 value. Okay? That's like your x1 comma y1 value. They want the distance from that point to the line y equals 2x minus 4. Okay, anytime we start these types of problems, here's what I suggest. I think that this is the best way to do this. I'll tell you, plot your stuff in decimals first. Plot everything in decimals. That's step one. So let's do that. Oh, decimals, where are you? Okay. Here we go in decimals. Quick question, kids. What point were we traveling through? We're trying to find the distance from 6, -2. Anytime you're applying a point, make sure you have your parentheses for an ordered pair. Call it 6, comma, -2. Okay, we're referencing from this point right here in red. Now, we're trying to find the distance from that point to, what was the equation of the finish line we're trying to get to? Y equals 2x minus 4. How many units from this line? I don't want to go from this red dot straight up. I don't want to go horizontally. I want to pass through this point in a path such that the path from through this point to that finish line is perpendicular. So the first thing we've done is plot our information. We need to find some distance between the point and the line. So back here, this is what I suggest secondly. This is what I suggest secondly. Find your perpendicular slope. Okay? In our finish line, what's the slope right there, kids? 2. So what's the perpendicular slope to that line? -1/2. It's the opposite reciprocal. So your perpendicular slope is -1/2. Okay? That's going to be your m value for point slope form. Okay? So the third part of this is very simple. We're going to use the information. What we take right now, we're going to put in decimals. Then we're going to take some stuff off of decimals and plug this into that distance formula calculator to find the distance. Here's how this works. Step 3. Write an equation for your path. We have to pass through that point perpendicularly to the finish line. Here's the equation. We're going to go y minus y1. What is my y1 value according to the point we're passing through? -2. So we're going to go y minus -2. That is equal to your perpendicular slope to your finish line. What did we say was our perpendicular slope, kids? -1/2, you bet. Times x minus x1. Or what's the point? The x value of the point that we're running from. We're running from to get to the finish line. X minus 6. Okay? This is your path that we're going to plug in. Now I could probably simplify the left a little bit, subtracting a negative. That left side is really y plus 2. So you might say, well, this is really y plus 2, Parson. That's equal to -1/2 times x minus 6. And the thing I love about doing this way is the following. I'm going to go ahead and type that path in field 3 in decimals. We have our path written. Okay? We plotted everything that we had. We found our perpendicular slope. We wrote an equation for the path and point slope form. So let's plug that into what we already have in decimals. Have you guys got this part written down here? Good. I'm going to need help. Okay, so field 3. Help me, kids. Y plus 2 equals -1/2 parenthesis x minus 6. Now guys, with a little bit of luck, this green line should pass through what? Does it pass through my point we plotted originally? Do we appear to have a 90-degree angle at the intersection of the green and blue line? Here's what I love about decimals then. The distance that you are kind of trying to find here is going to be between this gray point here, which is what? And the point that we started from, here. Once I've got that path in there and I know it's the right path, we simply have to say, well, okay, we need to find the distance between the point 2 comma 0 and what else? Okay, keep those points in mind. Let me show you something here. So, I'll do this as best I can. Squeeze this down a little bit. So now, which 2 points were we using? So I'm going to write this down. Use, don't make any acronyms up for this. Sometimes they get naughty. Distance formula calculator. And find the distance from, which points did we plot again in decimals? What were the 2 points that we had plotted here again? 2, 0, and what? 6, negative 2. Okay, so go to that new calculator that we bookmarked. Whoops. Right there. And plug your points in, kids. You're going to have 2 comma 0 in x1, y1. So you're going to type in 2 comma 0. Next one, you're going to type in 6 comma negative 2. And once you've done that, you're just going to want to go ahead and calculate that. Those are the 2 points I was looking for. How far is that point, 6, negative 2, from our equation y equals 2x? I can't remember if it was minus 4 or plus 4. How far is it away? 4.472. Okay, and I think your assignment, I can't remember when I sent it out. If they're asking around the nearest 10th or nearest 100th, I'm going to go nearest 100th in our notes. Okay? So here's the deal. Plot your stuff. Find your perpendicular slope. Put in your path. Pick your points and plug them into your new calculator. That's pretty simple, isn't it? Yeah. Okay? Now, doing this, we've got good tools to make, but you understand the process. Okay, let's take a look at another one. So I want to say, from this example right here, how far is that distance from here, kids, again? About how much? About 4.47 units. Okay? 4.47 units. Okay? That is your roadmap to finding the distance from a point to a line. Okay? This is about as easy as I can make this for you. Okay? Let's try another one. This time, in example 2, find the distance between what? You want the good news or the bad news? Well, it's good news. The good news is you know how to do this. The bad news is this is a lot easier than the top one. We should be challenging ourselves more instead of making it easier, right? Okay. In an example where you are trying to find the distance between parallel lines. Starts out exactly the same as example 1. What do you think step 1 is going to be? Plot your stuff in decimals. Guys, before I even plot this, how do you know that these are going to be parallel lines? Slopes are the same. Okay? Let's get to decimals. Let's do that. All right, let me clean everything out here. All right, in decimals, first equation is, maybe first expression. First expression is what? Negative 2x minus 2? Yeah. Okay. How about your second expression, kiddos? Negative 2x plus 3. And we confirmed that we've got parallel lines right there. Now our job is to find the distance between the orange and the purple line. I can't count vertically. I can't count horizontally. We have to measure in such a way that if some transversal was drawn between those parallel lines, the transversal would intersect and form right angles. The transversal would be perpendicular to the parallels, in other words. All right? So step one, we've plotted our stuff. Just like the first example, what do you think step two is going to be? Find your perpendicular slope. Here we go. Well, if the slopes of the parallels were negative 2, well, you tell me, what's the perpendicular slope for transversal going to be? How much? Positive 1/2. Okay? Now, last step is to write an equation for your path. Now, the path between two parallels is very nice because the path can be anywhere as long as you have the correct slope. And maybe this is the tricky part here. Your path to find the distance between parallels is simply y equals mx. Y equals mx. A lot easier than the other one. You don't have to put all those points and stuff. It's just y equals mx. Okay, because it doesn't matter where it goes. So what's the path going to be, kids? Y equals half x. Okay, check it out, kids. I don't have to put that in. Let me show you why here. Rhett brings up a great question. Do you at least have that part written down, kids?
Yeah.
Okay, let me go in here, Rhett. The deal is this. I'm going to go ahead and say I can get away with this because of the following. Why don't I have to put the intercept in? Well, here's the deal. I'm just going to type in y equals 1/2 x, like I suggested, right? Okay, in either case, that distance between it is the points from here to here, right? Agree with that? Let's suppose I knew that the intercept, let's just pretend the intercept that I wanted to put in was 6. You okay with that? Okay, what if I would have put something in like this? What if I would have said y equals 1/2 x plus 6. Brett, my question is this. How is the distance from here and here going to compare to the distance from, say, maybe here and here? They're going to be the same. So does it really matter where I put this line at all, the red line or black line? No, because no matter what, this little red segment from these 2 points and this little black segment from these 2 points are going to be exactly the same. So when you're dealing with two parallel lines and they say find the distance between it, all you really need is this third field right here. So in our example right here, I'm going to get rid of this one.
So never put a...
You never have to put intercept down when you're given two parallels. You just need to know the perpendicular slope and plug it into y equals mx. Okay? So guys, what's our last step now? Use the... Okay, we're going to use a distance formula calculator. So I'm going to go ahead and type this. Can you guys remember these points for me? Or do you have access to them on your Chromebook right now? Let me write this in here. So the next step here now is to use the distance formula calculator to find distance from, what were your points again? Was it -0.8?
-0.8, -0.4,
And 1.2, comma.
0.6.
Okay, so let's go into that. Let's go into this. Use your distance formula calculator. Plug your points in -0.8, comma -0.4, and 1.2, comma 0.6. And I've remembered from other sections today. But when I type that in and calculate it, you guys confirm what I've got as an answer. I calculated it to be about 2.24-ish. Are you guys getting the same? Okay, so it's about 2.24 on that. Guys, kind of your order of progression through this. First thing you want to do for any type of problem like this, plot them. Then find your
Perpendicular slope. Know if you're going from a point to a line or if you're just looking at parallel lines to know if you're using point slope form up here or just this y equals mx down here. Once you got everything graphed, determine your points. Use those points to find your distance between them. Grace.
I'm sorry, I sure can. Is that better?
Yep, thank you.
Here, I'll leave it. Can you read that okay?
Yeah.
All right. Any questions about this today, kids? Pretty cut and dry. Do the tools help you understand what's going on there? Okay, so I would say use them to your advantage today because, again, this is all stuff we've covered in the past. We don't need to reassess it. You know what you're doing there. So we're talking about finding distances. Let's use our tools to make that be successful.